Hello, and today we're going to be doing lesson 2.06, finding the surface area and volume of pyramids. Please don't forget to put your course and section number. For example, your course is 202B, your section number could be 1, 2, 3, or 4. The objectives in today's lesson are to define and identify parts of a pyramid, develop the formula for surface area of a regular pyramid, and then find the surface area of a pyramid. There were a lot of new terms. Some of them they're not so new. They're just used for pyramids instead of other prisms. But you got altitude, base edge, height of a pyramid, lateral edge, oblique pyramid, pyramid, regular pyramid, right pyramid, slant height, and vertex of a pyramid. And we're going to be covering most of these. Matter of fact, I think we're probably covering them all in this lesson. Okay, here you got a pyramid. Okay, and they labeled some of the point, or this point up here, the vertex. This triangle right here, they're calling the lateral face. This peach colored area down here is the base. This dotted line right here they're pointing to is a base edge. There's 4 of them in this one. All of these are base edges. And then this is an example of the lateral edge. Now then, I added some notes to this that when you're looking at a lateral edge, these are edges that are formed by the adjacent lateral faces. When you're referring to a vertex, this common vertex is called the vertex of a pyramid. It's where all the triangles come up to meet. Your lateral face of any pyramid is a triangle, and they're triangles that meet at the common vertex. And when you're talking about the base of a pyramid, that's a polyhedron that has one base that can be any polygon. Wait, let me read this and read it correctly. A pyramid is a polyhedron that has one base that can be any polygon. Remember, this looks like it could be a rectangle. Other pyramids may have a triangle base, a pentagon base, a hexagon base, and so on. And then when we're looking at the base edges, these are edges that form the base of the pyramid. Now let's look at right pyramids. Okay, there's right ones and there's oblique ones. And what we're going to learn about the right one, what makes it special, is the altitude of the pyramid is perpendicular line segment that joins the vertex of the pyramid to the plane of the base. This is also referred to as the height of a right prism. Now what makes a right prism right is this height or altitude goes straight from the vertex down to the center of the base, center being the key word there, and it's always perpendicular. Okay? Now the slant height, you got to be careful not to get these two guys confused. The slant height is the length of the altitude of the lateral face. So remember, your lateral face is a triangle. This slant height is the height of the triangle. Okay? This height is the height of the pyramid. Now let's look at oblique pyramids. Now, see how the altitude is in all wackadoodle different spaces, okay? It's never in the center. Because if it's in the center, it would not be oblique. It'd be a right prism. Look at the slant height. Whew, that's crazy looking. But this altitude is outside the pyramid. This altitude is inside the pyramid, but it's not in the center. And this altitude is on the pyramid. So you can kind of tell by looking at these pictures the difference between oblique and right. Now a pyramid is classified according to the shape of its base. So this one, the shape of the base is a triangle, so it's a triangular pyramid. This one, the shape of the base is a rectangle, so it's a rectangular pyramid. And over here we have a 5-sided base, so it becomes a pentagonal pyramid. Now when a pyramid is a right pyramid and has a base that is a regular polygon, It is considered a regular pyramid. Now remember, a regular polygon is a polygon that all the sides are equal. So this is a regular triangular pyramid. Look, triangle, all equal sides. This is a regular rectangular pyramid. Now remember, a rectangle that has congruent sides is a square, so we could also call this a square pyramid. A regular pentagonal pyramid, and look, all 5 sides are going to be the same length. Now to find the surface area S of a regular pyramid, you need the sum of the lateral area L and the base area B. Now here's a regular square pyramid. This is what it looks like when you lay it out as a net. And what they're saying, to find the surface area, you're going to need to find the area of each one of these triangles plus the area of the base. And when you go through the LMS, they show you how the formula is set up for finding the surface area of pyramids. But we're going to jump right into that formula, and I'm going to show you some examples. So here's the formula for the surface area of a pyramid. And then down here it tells us where L is the slant height. Remember, the height of the triangle, the lateral face. And P is the perimeter of the base. Remember, going all the way around. And B is the area of the base. So let's look at this example. It says for each pyramid, identify the variable that represents each of the following. So here we've got this triangle. Okay, so we've got to identify the height of the triangle. Well, you remember the height is the altitude, and it's going to be going from the vertex perpendicular to the base. Okay? So in this particular drawing, the height would be Z, perpendicular to base and intersects the vertex. Part B says, what is the slant height? Now remember, the slant height is the height of the triangle, otherwise known as the lateral face. So part B's answer says the slant height would be V, length of the altitude of the lateral face. And then C says, what is the side length of the base? Well, your side length of the base is going to be right here. Okay, so this answer reads, the length of the base would be X. Now this example says, find the slant height of each pyramid. Okay, so right here they've given us the height of the pyramid, and we've got the length of the base. And they want us to find the slant height. Well, you almost think they haven't given you enough information, but yet they have. Here you have a right triangle is formed by the point where the altitude intersects the base, the midpoint of the side of the base, and the vertex of the pyramid. So let me outline this. Let me do it in a different color so we can see it. Right here is where they're saying, and you can see I put a red dotted line in there. The height of your pyramid, okay, the height of the pyramid and the slant height, when I add this line right here connecting them, it becomes a right triangle. So now we found out we do have enough information to calculate the length of the slant height. Now look right here, it says the shorter leg is 1/2 the length of one side of the base, or 18 kilometers. See, your base is 36 kilometers. This red line right here represents half that length, which is going to be 18. The longer leg is the height of the pyramid. This is going to be our height of the pyramid right here. It's also the longer leg of our right triangle. So we're going to use the Pythagorean theorem to find the slant height, which is the hypotenuse of the right triangle. And I've started it out here. You've got 18 squared plus 24 squared is going to equal L squared, the slant height. And you calculate those, 18 squared, 24 squared, add them together, you get 900, get the square root of that, and you find out your slant height is 30 kilometers. Okay, this next example says find the surface area of each regular pyramid. Remember, this is our formula for our regular pyramid. Okay, the first thing we're going to do is find the perimeter and the area of the base. And remember, this is going to be the capital P and the capital B. And because the pyramid is a regular pyramid, the base is an equilateral triangle. Okay, that helps us know that if this side is 12 kilometers, then the other two sides are 12 kilometers. So our perimeter triangles have 3 sides, and then we plug 12 in for the side. 3 times 12 is 36. So our perimeter is going to be 36 kilometers. Remember how to find the area for a triangle is half your base times your height. So my base is 12, and they told me that the height of the base is 10.4. So remember, don't get all your heights confused, because if you're looking for the area of the base, here's the height of the area of the base. And I multiply all that out and I get 62.4. And so I found the capital P, found the capital B, now I'm looking for the L, and they give us the L right here. It's going to be the slant height, and it's 14.4. So now we just plug and chug. I'm not sure what this arrow is supposed to be, so just ignore that. So we're going to plug and chug. Here's our formula. We plug in the L, the capital P, and the B. We do the math. So the surface area of the pyramid is going to be 321.6 kilometers squared. Here's another example. It says find the surface area of each regular pyramid. So remember, since it's regular, that means all these sides have the same length. Okay? So to find my perimeter, the capital P in my formula, this is a hexagon. It has 6 sides. Each side is 12. So I plug that in, so to find out my perimeter is 72 feet. The area of my base, remember that crazy formula for finding the area of any polygon. It's going to be half the apothem multiplied by the perimeter. And see, they gave you the apothem right here is 10.4. The perimeter is 72, so the area of the base is 374.4 feet squared. And then our lateral height, slant height, there's all these dotted lines, it's hard to see, but right here it is. You see it, and it kind of blends up there at the top, but it's 33.6 feet. Now I'm going to plug and chug. Here's my formula. Plug in the L, plug in the perimeter, plug in the area of the base, do all the math there. So I find out the surface area of the pyramid is 1,584 feet squared. Whew, this is a long summary of this lesson today, but we learned what a pyramid is. We talked about the altitude of the pyramid and how to tell the difference between a right and an oblique. We learned that the slant height is actually the height of the lateral face. There again, we talked about a right pyramid and talked about what regular pyramids were. And then we learned the surface area formula for a pyramid. Be sure to read through your LMS and in your reference guide, completing the student guide for 206. Here's the problems you need to complete in your problem set. Just get your practice with surface area. And please contact me or attend TOGA if you have questions before completing the 2.06 quiz. And once again, make note of any general questions you may have when you attend CC on Thursday. And we will talk to you later. Bye bye. Thanks for listening.